So you get a super sharp image with really good color. So here is a stage micrometer. And what I like to do is use the stage micrometer to calibrate my digital measurements, because digital measurement is way more accurate and a lot faster. But you can also use it to calibrate your eyepiece reticle. And so what I use for digital measurements is Pixiemeter. And Pixiemeter is free software that only works on Windows, unfortunately. They make it in France. The download page is in French. But once you click the download link, the rest of it's in English. And Pixiemeter is cool because it does very little. All it does is measure things and add scale bars. So that makes it very easy to use. There's no features that you can get lost with. If you have Linux or Macintosh, then ImageJ is a good option. But ImageJ does a million different things, and I find it to be a little more confusing than Pixiemeter. But the stage micrometer lets you figure out how many pixels per micrometer your images have. So you could even use Photoshop for measuring if you want to do a little bit of math. So Pixiemeter gives you statistics like this. So I like to measure 30 spores to get a really good sample. And that takes a long time if you're just doing it optically. So with Pixiemeter, you're just clicking on the edges of 30 spores. It goes real fast, just takes a couple minutes. And then you get these statistics. This is the shortest spore and the median and the maximum size. And then here's the width. And then the Q is length divided by width. So it gives you an idea of the shape. And N is how many you've counted. And then the mean. And also Pixiemeter adds scale bars, which is really nice. You can save your image with a scale bar. And these days, a lot of people use cell phones for their cameras. I used to use DSLR adapters all the time in these expensive microscope cameras, but my micrographs come out so quickly and so beautifully with a cell phone that I rarely do that anymore. I will use a DSLR adapter if I'm trying to get really consistent micrographs, or if I'm trying to do image stacking, which actually works very well for microscopes, because the more magnification you have, the less depth of field you have. So being able to stack a whole bunch of images can give you a whole lot more depth of field. Though actually I don't stack very much anymore, because I find I get better luck just pressing down really hard on the cover slip. And what that does is it forces everything into the same focal plane. And that way it's all really flat and doesn't need to be stacked. But some things you can't do that because they're just too big. And so stacking can be really good. So with the cell phone, you have to hold it just at the right place. And by just at the right place, I mean, you have to get the X, the Y, and the Z, and the tilt. So 4 different things. You have to get them all just right. And then when you have them just right, you click the shutter and you get a real nice image. So you can use a holder. They're just like 10, 15 bucks on Amazon, and they will hold your cell phone at just the right spot. But generally, just the right spot is about 1.5 centimeters behind the ocular. It varies depending on depending on which phone you have and which ocular you have. But when you're using a cell phone, the autofocus is usually engaged, and that changes the size of the image, which isn't good if you're trying to do digital measurements. And also the size of the image changes about 10% depending on how close you hold the phone to the eyepiece. So what I like to do is make a little spacer, and that's just a piece of black tubing that's just the right length. I just saw it off with a hacksaw. It's usually, a black tube about 1.5 centimeters long and 1 inch in diameter. And that whole keeps the distance constant, and it keeps the angle constant. So you don't have to do that with your hand. And it also stops light from coming in from the side, which gives you more contrast. So when you start, you're usually using dried material. I definitely like using dried material. Using fresh material for microscopy is a real pain. And the reason for that is that you need to slice things extremely thin. And slicing fresh mushrooms is like slicing Jello extremely thin. You just cannot do it very well. So you can still do microscopy on fresh material, but it's a real pain. You'll never get those thin slices that are really nice for getting really good clarity and resolution. So when you have a dried mushroom, you usually rehydrate it with potassium hydroxide. You could also use like isopropanol. And there's a few chemicals people like for microscopes. Um, Water is the most important chemical. I usually use potassium hydroxide instead of water. But sometimes you don't want those color changes, so water is better. And a little bit of dish soap added to the water reduces air bubbles, and air bubbles are always bad and really annoying. A lot of people use stains. I don't use stains very much because I can see all these clear cells just fine without them. But for photography or something, the stains are really good. But a really important one is Melzer's reagent. And Melzer's reagent is a mixture of iodine, potassium iodide, and chloral hydrate. And that does a lot of different color changes. I'll show you a little bit more of that later. But Melzer's reagent is very hard to get because the chloral hydrate is illegal to have. It's a controlled substance. So usually you got to talk to a mycologist and they can get you a little bit of Melzer's reagent. So over here is one of these digital eyepiece things. These do not give you very good results unless you get a real good quality one. So a good one is like $300 or more, and they plug into the USB. And that's pretty nice. But if you get a cheaper one, then it's kind of like a camera with really high ISO where it's really grainy. And you won't like the results very much. You'll get way better results from a cell phone than you will from a cheap microscope camera. But over in the right, we have a DSLR adapter. So you can get these for Canon, Nikon, Olympus, and then you can plug your microscope directly in. You can put your DSLR camera right into the eyepiece. And these are kind of cool, but you sort of you get a couple issues with them. One is that when you press the shutter, it can shake the whole microscope. So I always turn the ISO down all the way. So you end up doing like a 2 or 3 second exposure. And that gives you really nice photos, but everything has to be completely still. So if anything's moving around in the photo, then that won't be good. And I don't use these too much anymore because cell phones work so well and you don't have to process your photos that way. But if you're doing image stacking, then you definitely want to use something like this. And what I do for image stacking is focus all the way to the very top part of the image. Take a picture, then turn the fine focus just a little bit, take another picture, keep turning the fine focus a little bit, keep taking pictures until you're at the bottom. And then you just take all of those and load them into Helicon Focus Stacker. Or if you don't want to buy something, combine ZP, and it will combine them into one image where everything is in focus. But the most important thing for getting a good image is slide preparation. And the most important part of slide preparation is getting the right part of the mushroom for what you're looking at. But the second most important thing is using a really tiny bit of material. So if you put a piece of just a little bit of mushroom on there, it's always going to be way too much. The right amount of material is an amount so small that you can just barely see it with the naked eye. So here is a cross section of a mushroom cap. And this is definitely a dried mushroom because you could never section a fresh mushroom like this. The very top here is just the top of the cap is called the pileopellis. And then the inside of the cap is the pilus trema. And then if there are any pleurocystidia, they will be here. And this is the face of the gill. You also have rows of basidia here that are growing spores. And then the inside of the gill is the lamellar trema. And then the chylocystidia will be here at the ends of the gills. So that's the gill edge. So the easiest and sometimes the best, the most informative thing to look at are spores. And spores are produced on Basidia and Basidiomycetes, or in ASCII and Ascomycetes. And they're pretty small. And the best way to view spores is from a spore print. If you have a spore print, that means that you're not going to have any mushroom tissue other than spores in there. And that mushroom tissue will force the cover slip up a little bit, so you'll never really get all the spores into the same focal plane. Also, if you take spores from the gills, not all of them will be completely mature. So if you have a spore print, then you can be positive that all of the spores were forcefully ejected and are fully grown. And then when you press down firmly on the cover slip, it will force all the spores into the same focal plane. So they'll all be in focus at once. They won't just all be like kind of bouncing around, and some of them in focus, some of them not. And you always want to use the highest magnification objective, which is usually the oil objective, which typically will be 1000 times magnification. You can buy microscopes that magnify more than 1000 times, but that's really just empty magnification where things are getting bigger, but they're not getting any clearer. So I think the best way to go is use the 100 times oil immersion objective with a 10 times 10 times ocular, and that gives you 1000 total. Here are spores of Psilocybe baeocystis, and these spores are smooth, and you can see like little kind of nodules inside of the spores, and these are oil droplets. So these oil droplets are food for the germinating spore. And then one feature that a lot of different genera have is a germ pore. So this is a germ pore here, a little break in the cell wall at one end of the spore, and that's where the mycelium will germinate from. And then so here's the germ pore here, and on the other side you have the hilar appendage. And the hilar appendage is where the spore connects stomata and the rest of the mushroom. So the mushrooms grow from that little knob or bump. And this photo I took with a differential interference contrast microscope. It was Nikon Eclipse 80i. And so I kind of like it because it looks like gold coins falling down from the sky. Here is tuber organense, and truffles have really beautiful spores. These spores are huge. They're about 80 microns long. They are inside the ascus right now. So this whole thing is an ascus. That's a 4-spored ascus. And these spores are really big and they're really thick. So I was not able to photograph everything just with one picture. So this is a composite of 30 pictures. I just stacked them, first focusing at the top and changing the fine focus a little bit. Sometimes you can just hold down on the shutter in continuous shooting mode and then just slowly turn the fine focus until it takes your whole stack of pictures. But then I loaded them into the free software Combine ZP, and it was able to turn those 30 pictures into one picture where everything is in focus. A lot of truffles have really cool spores. But even cooler spores are an Asterophora lycoperdoides. And these spores are up in the top of the cap. And this is a stack of about seven photos I took to get them all in focus. Here's some stained with cotton blue, and some not stained. And then Tricholosporium is a tropical genus that has crusate spores. So if they're oriented just right, you can, like this one here, you can see the spores have the shape of a plus. And then here's an Amanita from section Lepidella. The Amanitas all have white spores, but section Lepidella has amyloid spores. So these are mounted in Melzer's reagent, and the Melzer's reagent reacted with some starch-like compounds in the spore wall to turn them blue. So if Melzer's turns a spore blue, that means it's amyloid. And if it turns a spore red or reddish brown, that means it's dextrinoid. And if it doesn't do anything, then it's inamyloid. So this is a really good thing to do in Amanita because all of the deadly Amanita species have amyloid spores. So if you throw a little bit of a gill and you see spores, and it's in Melzers and they're not turning blue, then you know the Amanita will not kill you. There's some edible Amanitas that have amyloid spores, like section validae. So you got to do more than just look at this. But if you wonder if your mushroom's deadly before you fry it up, this is a really good way to check. Here is Lactarius fragilis. Now Lactarius rubidis. Those are West Coast candy cap. And everything in Lactarius has amyloid spores. And you can see that they have these ridges along the spore wall. So they're kind of cool. They're like little walls on the wall. And a lot of Lactarius do this where they have these ridges. And then other Lactarius have its spines. But these are white spores that are turned purple with Melzers, so it's the amyloid reaction. And then this is a photo I took with a phase contrast microscope. And phase contrast microscopes give you lots of extra contrast. They kind of introduce some artificial colors. So this is a 15 septate spore, which means it has 15 divisions or 16 segments total of trichoglossum. So this is those black earth tongues. And you can see these spores are really huge. If you look at the scale bar, these are 50 micrometers. So these things are like 160 micrometers long, but only like 10 wide. So this is what it looks like in phase contrasts, almost like a work of art. But with just a regular light microscope, this is what they look like. So your colors are much more accurate, but they don't look nearly as cool. Here's Psilocybe subaruginosa. You can see the germ pore pretty well, and the oil droplet and the hilar appendage. And here's the same thing where I added the scale bar and the measurements with pixie-meter. Here's Psilocybe cubensis. These have a really thick spore wall. Looks like pumpkin seeds. Psilocybe subtropicalis has more rhomboid-shaped spores. And here is Lepiota sphenincospora spores in Melzers. And these are white spores that turn red in Melzers, so they are dextrinoid. And these are penguin-shaped spores. These are bullet-shaped spores from Lepiota castanidisca. You can see Lepiota has very cool spore shapes. They look a lot like wedges. And then here's oyster mushrooms. These spores are real thin and long. And so this is with the light microscope, and this is with phase contrast. And you can see the phase contrast gives you a whole lot of extra contrast, but it makes it harder to see what color they really are. Pineolus phonisecii has these really roughened spores. So you can see the bumps on the outside there. And most species of Pineolus are very smooth. So this is the easy way to tell Pineolus phonisecii from some of the other ones you'll find in lawns. A lot of Inacibes have very boring spores. They look kind of like beans and no germ pore. But then there's also really cool Inacibe spores. Inacibe gramata has these nodulose spores. So after spores, the next thing I usually look at are Chylocystidea. And Chylocystidea are cystidia that are on the very edges of the gills. They're really good for identification, and they're best viewed with a crush mount. And the reason I like to view them with the crush mount is that when they are embedded in the gill, you only see the top half sticking out. You can't see the whole shape. You can't measure the whole thing. So by pushing down firmly on the cover slip, pretty hard, but not quite hard enough to break the cells and break the spores, then you'll separate all of these cells and kind of have them floating around free, and that way you can see the whole thing. But if you're looking for Chylocystidea and you're doing a crush mount, it's pretty important that you have only the gill edge on your slide. Because if you have some of the gill face on your slide, then you're going to have a mix of Chylocystidea and Pleurocystidia, and you won't know which are which. So here is the gill edge. And this is a photo that I took with a compound scope, but I'm using it like a dissecting scope. I just shined light down with a LED headlamp when I just have a fresh cap on my microscope at low magnification. And that way I can see what the gill edge looks like before I crush it. So these are the Chylocystidea that are sticking out of the gill edge. Here is a Gymnopolis luteifolius, and you can see that the Cheilocystidia in Gymnopolis are very often shaped like a bowling pin. So they look like this, and then the edge of the head is swollen. They call this capitate. This one is not very swollen, so I would call it subcapitate. These are a little bit more capitate down here. And in Gymnopolis, there's also just a huge amount of orange color everywhere. So you can see that all over the place. Here is Psilocybia lenii, Cheilocystidia. So this is a crush mount. You can see a few of them sticking out of the gill. You can see like these here, you can't really see the whole thing, but here you can see the whole thing very well. So here it's like a bottle shaped with a kind of acute apex here. And then sometimes it's wider and more rounded. Here's some more bottle shaped ones in Psilocybe subaruginosa. And this is a microscopy composite. So I took a few different pictures. Each picture had one or two Cheilocystidia that were in focus well. And I used the clone tool in Photoshop or the GIMP to move all of the Cheilocystidia into one picture. And that's a good way where you can kind of see all this stuff and not have a bunch of garbage in your photos. Here's Psilocybe youngensis. This one's unique because it has these simple Cheilocystidia here, but it also has these large Cheilocystidia that are bifurcate and trifurcate. And here's Psilocybe quebecensis. This is the edge of the gill before I've smashed it. So you can just see all of the Cheilocystidia just coming right out of the edge. Here is Psilocybe mexicana, and this is phase contrast. You can see up here, this is a Cheilocystidia. It looks like it has rabbit ears because it's bifurcate. Over here, there's a basidia. You can tell the difference between the Cheilocystidia and the basidia, often because of the contents, the texture of the contents. Basidia often have granular contents, like you can see here, in sharper sterigmata, whereas cystidia usually are just clear. They call it hyaline, and not so much crazy stuff inside of them because it's not making spores. So the phase contrast looks really cool, makes the spores look like golden eggs. Here's a basidia that's just starting to form the sterigmata, so an immature basidia. And then here is a paniolus. Paniolus often has, these are cylindrical Cheilocystidia. So, it's sort of like a cylinder, subcapitate right at the apex, so it's swollen just a little bit. Pluteus cervinus has pretty cool Cheilocystidia. Often they'll have these horns up at the apex of the Cheilocystidia. So next thing that I like to look for are basidia. And basidia is the plural of basidium, and these are what grow the spores. And so usually in most mushrooms, you got 4 spores growing on each basidia, sometimes other numbers. And before the basidium is mature, it's a basidiole. And sometimes it's kind of hard to tell which one are basidioles and which are basidia. And often you just have to look at a bunch of basidia and see what the difference is. And how exactly you tell that really depends on the species. So Copelandia bispera is named after the 2 spored basidia. So here's a basidia here with a sterigmata coming out of it, and only 2 spores growing on each one. Here's one that's already ejected its spores. Looks almost like a slingshot. And then here's a 4-spored basidia. So you always tell that something is 4-spored because you see when the spores have not been ejected yet, they are in groups of 4. So here are the basidioles. They are basidia that have not grown the sterigmata yet, and then some mature ones over here. And then the pleurocystidia are also very taxonomically significant, and those are on the gill faces. So the gill face is the rest of the gill that's not the edge. So they're pretty important for identification, like in Candoleomyces, which just got split off from Sapphirella. They never have any pleurocystidia, yet most Sapphirella species have pleurocystidia. So looking for this pleurocystidia is a really good way to tell if you have Sapphirella or Candoleomyces. Here's some pleurocystidia here. Bottle-shaped is a very common shape for them. In Coprinopsis atramenteria, the pleurocystidia separate the gills. And so they're very large, kind of pushing the gills apart, leaving just enough room for the basidia to eject the spores and the spores to fall down in between the gills. And in Paneola subgenus Copelandia, you have what are called metalloid cystidia or metalloid pleurocystidia. And these are very thick-walled cystidia, which have a lot of colored pigment and a sharp apex. These are interesting because if you mount them in water, they're bright green. And if you mount them in potassium hydroxide, they turn brown. So it's best to mount them both ways. Inocebi are some of the most boring mushrooms to look at when you just see them, but they're some of the most beautiful mushrooms under the microscope. They often have calcium oxalate crystals at the apices of their basidia. I think this is probably to annoy slugs that would try to eat the spores. And then the spores in this case are stellate or star-shaped. Pseudocystidia is these little cystidia that grow, they grow directly out of the gill, directly out of the lamellar trema. So the regular pleurocystidia grow from the subhymenium, which is above the lamellar trema. So pseudocystidia are deeper in the, they originate from deeper within the gill. Here's some from Psilocybe zapoticorum. The pileopellis is the layer of cells on the top of the cap. So it's the very top skin of the mushroom. And it's usually viewed in a cross section because if you do a scalp section, you can't really see the structure, but with a cross section, you kind of get to see all the different layers. And so you have to, you almost have to have the material dried because it has to be really thin to get any kind of resolution on this. Here is Psilocybe pseudoasticorum, and in this, the pileopellis is an isocutus, which means that it's kind of gelatinized. And by gelatinized, basically it means that the cells are there, but you can barely see them in the microscope. It just kind of looks like an amorphous mass. So this is in the field, when you find something like this, it's kind of like a little layer that you can peel off the top of the cap. So this is the very top of the cap here, the pileopellis. And if you don't have a spore print, the pileopellis is a really good place to find the spores because you know these spores were forcefully ejected and therefore they are fully mature. And then down below here, you have the pilus trema, which is just the middle of the cap, the inside. Here is Puteus chrysophlebus, and this pileopellis is called a trichoderm. And what it looks like is a whole bunch of round rocks that are stacked into a wall. The lamellar trema is the very inside of the gill. And to view this, it's best to have a dried gill and just set it down on a dissecting scope and then use a brand new razor blade to cut a whole bunch of different pieces as small as you can, make like 20 pieces, and then throw away the big ones and only mount the very smallest ones. And then you'll be able to see how the cells are arranged inside of the gill. This is really good for separating Amanita from Leucoagaricus, because they have a different lamellar trema. So here's a cross section of a gill, Psilocybe pseudoasticorum. The lamellar trema is in the middle here. And then up here, you have the subhymenium. And then the basidia will grow out of the subhymenium. The pleurocystidia also grow out of the subhymenium. And if there is any pseudocystidia, which there's not in this photo, they arise from the lamellar trema deeper down here. Here's some lamellar trema stained with Congo red. This would probably be sort of hard to see the individual cells, especially in a picture if I hadn't stained it. And over here on the left side, you can see that it's very, very thin section. You can see the cells in the lamellar trema really well. Over on the right side, it gets thicker. You can't really see what's going on over here. So you can see for looking for a feature like this, you really want the very thinnest, only one layer of cells thick. And then the subhymenium is between the lamellar trema and the basidia.
Hang on, I have to mute somebody. Sorry about the noise.
Go ahead. So down here is the lamellar trema and the subhymenium right here, and then the basidia up above that. And then pileocystidia are cystidia that are growing out of the top of the cap. To see these, you can do a scalp section of the pileopellis, which means you just slice a little bit off of the top of the cap. So here is pileocystidia and tricholosporium. The pilus trema is the very inside of the cap. This is a really good thing to look at in Gymnopolis, and unless your section is extremely thin, you're just not going to see anything at all. But this is pilus trema. You can see it's nice and thin up at the top. At the bottom, it's too thick. You can't really see much. And a lot of your sections are like that. They're really, really thin on one side, and then they'll get thicker on the other side. And the best thing to do is just slice off that thicker side before you mount it on the slide. So you only have the really thin part that you want. Clamp connections are only in basidiomycetes. So if you're wondering if what's growing on your auger is the mushroom you're trying to grow or a contaminant, a good thing to do is to look for clamp connections. And there are little bumps right at the place that two hyphae come together. And you usually see them in crush mounts. So here you have Puteus cervinus. You got, here's one hypha, here's the other hypha over here. Here is the septa that divides the two hypha, and here's the clamp connection. And it's exchanging genetic material from one cell to the other through this bump. There's another one over here, another one over here. I meant to put some resources in here, but I didn't have time, so I'll just tell you about the resources. And this is my last slide. Then I will give Maricel some time to talk about crust microscopy. A really cool group for learning about this and discussing and posting your photos is called Fungal Microscopy on Facebook. And this one has been doing pretty well recently. There's a lot of people posting a lot of really beautiful micrographs on there and asking questions. So people get advice about microscopes and how to use their microscopes and just show what they have found. So fungal microscopy is really cool. Another really cool group is called amateur microscopy. And amateur microscopy is not just for fungi. So there's a lot of diatoms on there and bacteria, plants, all sorts of stuff. A lot of really beautiful content on there. And there are a lot of microscope nerds, especially on amateur microscopy. There's a ton of people that are just do microscopy for a living and are extremely giving with their time to help out people, pick a microscope, decide if used equipment is any good, or just kind of decipher what they've seen. So amateur microscopy is really cool. And like whenever I see some expensive microscope on eBay and I want to know if I should buy it, I'll just post a link to amateur microscopy. And there's a lot of people on there with a lot of experience who are happy to tell me like, oh no, don't buy that one. You should get this one instead. Or that, yeah, that one will do what you want to do. So amateur microscopy is really good. There's also a microscopy tutorial and I have a link to it up on Mushroom Observer. But if you want this microscopy tutorial, just message me and I will send you the PDF. There's really no good books on microscopy of fungi. There's one called How to Identify Mushrooms to Genus Part 3, and it's about 40 or 50 years old now. It's good, but it's really old. This microscopy tutorial, it's in PDF form and it's way better. And so I can send that. And also I'm happy to answer questions about microscopy. So if you have any microscope questions, or if you've taken pictures of something and you want to know how to interpret, turn your pictures into useful information, you can send them to me and I will help you out, or help you figure out which kind of microscope you need, where to get a good deal on it, or if a used one is a good one to buy. So don't hesitate to contact me. I'm always happy to answer microscope.
They always advise to do it when the crust is dry. Alan already said why it's easier to cut it, but I try both. And it's very important to do the microscopy because there are many species that look alike, but only when you go to see the microscopic features, then you will know which one is which.
So why don't we go to Q&A? There was a whole bunch of people who had questions. Continue to paste your questions into the chat and I will call on you. So the very first question, actually, Ilan had several questions. So why don't you get started, Ilan? You had questions about microscopes.
Oh, I don't even recall the questions I had.
Okay, I'll read them for you. What brand model is your compound scope was your first question. And then share download URL for ImageJ, we did that. And then do you use cell phone camera on trinocular ports?
So the compound scope that I have right now is an Olympus BX41. And I got that one just about a week ago. It's really nice. It's big and heavy. It has very clear optics. But I also have an Amscope B120. So that's like the $200 one, and that one works really well too. And I also have Zeiss, and that one's good too. The Zeiss are very upgradable. There's a lot of parts around for them. But yeah, I think for most people, just when they're going to get a scope, then that Olympus, or no, the Amscope or equivalent Swift or Omax is a good one to get.
Okay, great.
There was a question though in regards to using the cell phone. Do you use that on the trinocular port?
Yeah, the trinocular port is the same as the other ports, so you can use a cell phone on it, or you can just put a camera up there, and then you can have the image just go to a computer screen, and that's kind of nice because then you can sit back in your chair and look at the image. But yeah, it's the same. The trinocular port is exactly the same as the two in front.
Okay, great. So Michael Moser, you had a question.
I think my question was answered. I was interested initially in how you, I'll turn on my video too. I was initially interested in how you take photographs, which is incredibly frustrating for me. And that spacer tip that you gave us is fantastic. So I'm looking forward to making one of those. And I think that was pretty much it. I find microscopy very frustrating. And so all of your tips are going to be nothing but helpful. I really appreciate it. Thank you very much.
Well, yeah, I agree with you, Mom. Microscopy is very frustrating at first. And the way I learned is absolutely the wrong way to go about it. What I did is I just bought a microscope and I sat down in front of it for like an hour a day for years. and I was extremely frustrated. But I eventually, I wanted to learn it so badly that I eventually figured it out. But I could have saved years of time if I had just asked somebody that knew how to do it, a few questions, and maybe got together with somebody who was really good at it. So that's what I recommend doing. And, these days there's all sorts of online resources. Back in 2007, when I got into this, there wasn't very much. You didn't have all the fungal microscopy Facebook group or the online community that can really help you out with that. As far as taking pictures with a cell phone, that too is extremely frustrating at the beginning. It takes a lot of muscle memory to be able to get it working reliably. And so when I first started out, it's like you put the phone up there and it's like moving all around. And when you want the image to move right, you have to move your hand left and vice versa. So, after after you've done it a bunch, it's just second nature and it's really easy to get the image centered. But the first few times, it's really hard to keep it centered. One thing that's really helpful is you put the phone kind of back from the eyepiece, several inches, maybe even a foot, and you see this bright spot on your phone, and that's the light coming out of the microscope. And then you move the phone slowly towards the eyepiece, keeping that spot in the very middle of your phone. And that way, when you get it to the right distance, then you'll see the image nice and clear. So that helps you, hone in on the right place. And not only does the X and the Y have to be right, so it's like the right and the left and up and down, but also the distance of the microscope from your microscope objective to the phone has to be right. And to get that right, I usually I'll rest my fingers on the ocular and then rest my phone on my fingers. So I kind of use my fingers as a spacer. And that helps a lot. And also the microscope, the cell phone camera has to be very flat. It can't be tilted at all. Or if it is tilted, then the image will not be in the center of your camera on the phone. It'll be like off to the side. So that also takes some practice and some muscle memory. And the spacer really helps a lot with that, because then you can't get the tilt wrong.
Great.
Amazing. Thank you.
All right, John Dawson, you had a couple of questions.
Yes, the first question was simply, what do you recommend for cleaning microscope lenses, getting the little tiny bits of debris off? The second question, when I'm using oil immersion at 1,000 times and trying to do some focus stacking, when I have a spore that I can't see the warts and the spore itself in the same focus, I find that when I try to change the fine focus, it causes the objective to press on the cover slip, causing the fluid to move the spores and thus thwarting the focus stacking. Do you have any suggestions to solve that problem?
Yeah, I'll answer your second question first. That one is probably because your slide is too thick. So if you can use a spore print instead of a gill, then that will make your slide thinner. And so if you can scrape a little bit of spores from a spore print onto the slide, and then add just a very small amount of water, and then press down very firmly on the cover slip, not quite so firmly that it breaks the spores, but almost that hard. That'll force all the spores into the same focal plane. And it'll also stick the cover slip very firmly to the slide, so the things won't be moving around very much. Another thing that's really helpful is to use fingernail polish, and you paint a ring around the cover slip after you've pressed down firmly with fingernail polish, and that seals the edges, and that stops water current from flowing underneath the cover slip. So it keeps the spores from moving around like crazy. But I think most of your problem is just that you have too much material on there. And when you have too much material on the slide, then it's not completely flat. The cover slip is not completely flat. And when you get to the higher magnifications, like 1,000 times, then it's just not going to work very well if it's not completely flat. So what you can do if you don't have a spore print is just use an extremely small amount of material. If you use an amount of material so small that you can just barely see it, or even better, you can't even see it with the naked eye. That way, your cover slip will be able to sit very flat, and then the objective will not actually be touching the cover slip when you're using it, and then it won't make the spores move around. About cleaning the objectives, everyone has different opinions on that. One thing I like a lot is isopropanol. So just isopropyl alcohol is pretty good. I also really like Windex. And there's, a big issue is those little fibers. So something that doesn't make a lot of fibers is really good to use. Often I'll use microfiber cloth. And a lot of times those microfiber cloths are pretty cheap. Often you get them for free with like when you buy eyeglasses or something. But you can cut them into little tiny pieces, and that way you can use a little bit and then throw it away so it stays very clean. You're always using a clean piece. Because it's so small, you don't need very much. And then when you're using the 100 oil immersion objective, it's really important to clean the oil off at the end of the day. Because if you don't and you forget about it and it stays on there for days or weeks, then the oil hardens and makes kind of a film that you'll have to dissolve off with a solvent like isopropyl alcohol. So that is important. And then one more tip is that when I'm cleaning optics, one thing I really like to do is use a very bright light. And usually I'll use ultraviolet light for this, though I think it works just as well with regular light. It's just the ultraviolet light is really fun. But I have a Convoy CA ultraviolet flashlight, which is an extremely bright ultraviolet flashlight. And everyone should buy one because it's really fun to walk around at night in the woods with one. You can even use it for fluorescent photography by shining it at your sample when you turn off your microscope light. But one thing that it does really well is that it makes the dirt or debris or any kind of dust show up really well. So if you shine this really bright ultraviolet light at a very high angle at the thing you're trying to clean, you'll be able to see very well whether it's clean enough or whether you need to keep cleaning to get it absolutely clean. And that's really useful if you're trying to clean like the inside, like the prism on your microscope, or the eyepieces especially, or a camera sensor, lots of different things.
Thank you very much.
Great, thank you. Then Overton, you had a question.
Hi, thank you. Nice presentation.
Thanks.
My question is about having a pharmacist make up some Meltzer's reagent for me. I've seen the recipe that's online. It calls for chloral hydrate, and she can only get a bottle of 10% chloral hydrate. Will that make an adequate substitute if it's mixed with the iodine and potassium iodide?
No, because the amount of chloral hydrate that you need is very large. You'll notice when you look at the recipe that it's almost 50% by weight. So 10% would be 90% water, and you won't never get enough chloral hydrate to make the recipe properly. But it's likely you could evaporate that down, ideally with a vacuum pump. But if not, then maybe you could just evaporate it. Or you even boil it away. So if you can evaporate your 10% so you get the chloral hydrate crystals, then you'll be able to use it really well. So I think that's not super hard. And it's really cool that you can even get 10% because most pharmacists can't get it at all. One time I was able to order chloral hydrate crystals on eBay from the Ukraine. And I ordered it, and about 2 months later it came, and they made the box that they send it in from old laundry detergent boxes. So it was very interesting packaging, but it was really good chloral hydrate. And I made a whole lot of Meltzers with that, and have given it all away now. But anytime that somebody's able to get chloral hydrate, I always take them up on the offer because it doesn't come around very often, and it is really hard to get.
All right.
Thank you very much.
So Ilan, you had a question about software.
Okay.
Yeah, so I'm Mac based, and I was wondering what's the best software to use for either image stacking or spore measurements, which I think you kind of covered on the Mac side.
Yeah, so I think ImageJ is pretty good for spore measurements. For image stacking, I haven't had a Mac in a while, but there's two main softwares that the professionals use for photo stacking. They are Helicon Focus Stacker and um, Zerene Stacker. I imagine both of them probably have Macintosh versions. And they're both commercial software, but they both have free 30-day trials. So what I did is I downloaded Zerene and used that for the free 30-day trial. And once that ran out, I downloaded Helicon, used that for 30 days. And so after 60 days, I decided that I liked Helicon better because it was faster and simpler. And so I bought Helicon. So I'd recommend doing that.
All right.
But also I bet Combined ZP works on the Macintosh as well. And that one's free. And I have not compared it to the commercial ones, but I think it compares pretty well. And also Photoshop does photo stacking, but it's not nearly as good as the ones I mentioned because it's just not nearly as smart about picking which layer to incorporate in the final image so you get more artifacts. But you could also give that a try and see how you like it.
Okay, great. Rima, you had a more general question.
Hi, Alan. Thanks so much. Really, really enjoyed it. I'm just curious about how you got interested in mushrooms and if you can tell us a little bit about your journey. Thanks.
I started looking for mushrooms in like 2001 because I was out hiking and this was like Christmas Day in 2001. There was mushrooms everywhere. It was a really good season. And I thought like, wow, so I wonder which ones are rare, which ones are poisonous, which ones are edible, if there's any hallucinogenic mushrooms near me. And I didn't have any idea who would know that kind of thing, but I knew there were people out there that did know this stuff. Back then, those people were pretty hard to find. And so I started taking pictures of mushrooms and paying attention to them. And wherever I saw mushrooms, I'd pick them up, take a close look at them, taste them and smell them and all that kind of stuff. And so that's how I kind of got started. Back in 2001, I was working for the government doing computer hacking for NASA. So I was just kind of going out on all my lunch breaks, looking at mushrooms on my lunch breaks and after work and on the weekends. And then in 2007, I started to go to Mexico to look for mushrooms. And there were so many cool mushrooms down there. So I started to get more serious about it then. And in 2012, I quit my job just to do mushroom stuff full time. And so that's where I'm at now.
Thank you for that.
Thanks.
So Ellen Rice had a question for Maricel.
Hi, thank you. I'm learning so much. I'm in Western Washington, and we survey a little rural road intensively. We've got crusts in the fall, and I don't know where to start. So I was wondering if you had some resources that you would recommend.
Yeah, so there are not too many books about crust fungi, but there is a group in Facebook called Crust Fungi and Polypus, and you can start right there. You can you can post your photos with a lot of details and your microscopy. Microscopy is very important for crusts because you can find like 80 white crusts. So how do you know what is what?
Yeah, there you go. That's my problem.
Yeah, you have to do microscopy, and even some of the experts in this group in Facebook, they tell you no microscopy, no ID. Yeah, but people insist posting crusts without microscopy.
Well, if you bring your microscope and come to Western Washington, we'll give you a cup of tea.
Oh, nice! I did that. I went to Georgia with a friend, and I brought my own microscope, and we found crusts for 1 week.
There's a lot out there. There's a ton that we're missing. Okay, thank you.
Yes.
Thank you. Ethan, you had a question.
Yeah, I think a lot of times people get very comfortable with their own particular setup and their own particular way of working, and don't realize how idiosyncratic or counterproductive that their way of working can be. And in my particular setup, I'm taking pictures through the barrel of the microscope, but the way I'm set up, it requires me to remove the ocular, which has the measurements in it. It has the micron grades in it. And so it's a kind of a clunky setup, but I sort of calibrate my own cell phone photographs to my stage micrometer. And I was just sort of wondering, like, I imagine you have, when you're taking pictures through the with the cell phone, it has the measurements in the picture itself.
Well, it would if I had a ocular that had the reticle in it.
Oh, you
but
don't?
all the oculars I use these days do not have the reticle in them. So what I do is I take the picture with the cell phone, and then I make sure I use a special app that does manual focus on the cell phone, so the cell phone isn't trying to autofocus. On Android, a good one is called FJ Camera. And then I use a spacer to keep the the cell phone a constant distance, so that way my measurements don't change from picture to picture. And then I use a Piximeter to take a picture of my stage micrometer with each objective, and then just load those calibrations in. So that way, as long as I know which objective I used, I just select that in Piximeter, and then I can do the measurements accurately, and I don't have to have the reticle. So the reticle I really only use for measuring just by manually, just with my eye. And it's a lot slower that way, and not nearly as accurate. So that's why I haven't bothered to get a reticle in a long time.
Okay, thank you.
All right. Stephen Bodson, you had a question.
Yeah, no, you answered about the cleaning. That was my main question. I do actually have one other, which is whether I've kind of been enjoying also doing opaque microscopy using, like, I rig up my bike light on the microscope. It's got a incredibly intense LED, and I'm able to get up to about 250x. And I'm wondering if there's, if you have any tips about opaque work as well, because
yeah, I mean, that's called epi illumination, and it's really cool. You can get a lot of really cool effects that way. So the brighter the light is, the better. I have this thing, I call it a light sprayer. I don't know what it's really called, but it's a fiber optic thing. And so it has an LED light on one end, and then a stainless steel hose full of fiber optics, and then the light comes out the other end. And with that, you can get it really close to your subject. And then since the LED is so far away, it doesn't heat the subject up. So that works pretty well. Also, just like a really bright LED is really nice for that. Some of the newer headlamps have extremely bright LEDs. They can have like 4,000 lumens, which is ridiculous. It's almost as bright as the sun. And so those can give you like a whole lot of light. Also, it's really fun to use ultraviolet lights. So you can, if you have a pretty bright black light, then you can see how things are reacting in ultraviolet on the microscope. And if you have a fluorescent mushroom, you can see which parts of the mushroom are fluorescent. And then if you don't have a very bright ultraviolet light, you can hook a DSLR camera to your microscope and do a long exposure to get the exposure you need. But there's a lot that can be done shining lights from above and from the side onto an opaque sample. And you don't even really need a stereoscope for it. On the lower power objectives, the 4x objective or the 10x objective, sometimes the 20, but then you get the shadow gets of the objective gets in the way and blocks a lot of your light. But yeah, you can see really cool stuff that way. And you know, the higher power you go, the more depth of field, the less depth of field you have. So if you have like some kind of opaque object, you'll usually want to do focus stacking to get, you know, everything in focus at once. And if you do that, you'll get some really nice results.
Great. Ilan, you had yet another question.
Hey, thank you for answering my questions. I wanted to ask you about using a microtome for sectioning a mushroom, or does that only really work when you're using like on a stipe or something like that?
Most people that do microscopy don't ever use a microtome. I think for cutting mushrooms, the best thing is a brand new razor blade. I've heard that Feather is the sharpest brand. So you order these razor blades, you snap them in half before you open up the packaging, then you get 2 of them. And you can slice things extremely thin with one of those things. The microtomes, usually on a dried mushroom, it'll just kind of crush it, and the microtome will just break the mushroom rather than slice it. So with a lot of microtomes, you encase it in wax. But then you got a bunch of wax around, and I actually have not tried a microtome. I have it. I would like to give it a try, but I think most professional mycologists that have microtomes just end up using these little razor blades.
Jim Anderberg, you had a question.
Yes, I'm looking at microscopes, and one up they mention these curler illumination, if I'm pronouncing that right. Is there an advantage to that?
The curler illumination, if you ask any microscope professional, they will say that curler illumination is absolutely essential to get your contrast correct and to get the best resolution. In my experience, it doesn't really matter very much. The professionals really don't like this, but what I do is I sit down in front of the microscope and I just you know, look through it and mess with all the controls. And by all the controls, I mean the field diaphragm, the condenser diaphragm, and the distance of the light to the bottom of the stage. And just kind of turn all of those knobs until I like how the image works best. What you're supposed to do is set up curler just right. And to do that, you take the eyepieces out and you adjust it a certain way, and you put the eyepiece in and adjust it a certain way, and then you're supposed to have the best resolution, best contrast. And it's supposed, and that's the way you're supposed to do it. But in my experience, every time I do that, I don't like how the image looks. And so I always go ahead and misadjust it until I like how the image looks. But I think you will have more options to have like better illumination with a microscope that has the curler feature. So if you can afford it, I would get something like that, because that indicates it's a better microscope. It indicates that the manufacturer designed the microscopes for people who really know what they're doing, and it'll give you more options for illumination. And definitely try those instructions where you set up curler just right, because you can use like half of that procedure like on anything, and then just once you get the curler set up just right, then adjust the condenser diaphragm to however you like the image to look, and then you'll kind of get the best of both worlds.
Thanks.
Thank you. Michael Moser, you had another question.
Yeah, so in terms of the lighting, I wonder if you do for all your different techniques for getting really good light, or the UV lighting, do you find that it helps you to be in a completely dark room so that you can see the subject that you're looking at more precisely, or does it not make a difference?
It helps a little bit. It's not a very big difference, but if you're not in a dark room, then you'll have light entering both the microscope, you know, through the objectives, through the eyepieces, and it coming into the camera at all different angles. and that will reduce your contrast and make everything a little bit more kind of bleached out. So definitely try it both ways, but all things being equal, a dark room is going to be better.
Okay, thanks.
All right, we're going to ask one more question. Ilan, you get to have the last question.
Thanks. So Garrett Taylor, who's on the call, kind of guided me towards the Swift 350 trinocular scope, which has like a dark field filter holder. And I was wondering if you have any experience with dark field filters and if you can recommend any specific shapes or sizes. And I've had a few that have been 3D printed, so I just want to know if I should be looking at 3D printing a specific size.
Yeah, I think dark field is really cool. It's not really something that will help you with your scientific goals, but it will definitely make really cool art, and it's really fun. So I like dark field a lot. And I have not experimented very much with those dark field filters. I have a little bit and haven't been very happy with the results, but that's probably my fault more than the fault of the filter. I noticed you can go on eBay and get a whole bunch of dark field filters for like 20 bucks. You can get a whole bunch of different sizes. And that seems pretty tempting to do, but I'm not really sure which ones will work best. Another really cool technique is Reinberg, which is like dark field, except instead of having an open space around the spot, the dark that blocks out the light, you have a different color. And what it does is it changes the color of the background. So you can choose the colors both for the illumination and for the background. So for example, yellow and blue has very high contrast. So you can set the background to blue and your subject to yellow. And stuff looks really cool that way.
All right, I think those were all of the questions. Thank you both so very much for this fascinating presentation, amazing pictures, and for taking the time to answer all the questions today. That was really great. Very much enjoyed it. Thank you so much.
Thanks.
All right. Bye, everyone. And remember that Alan's on Facebook, on Mushroom Observer, on iNaturalist, on Instagram. And he's usually very good about answering questions in some of those groups that we mentioned. So those are great resources.
Yeah, if you got any more questions, send me an email or a message on Facebook, iNaturalist, Instagram, Mushroom Observer, wherever.
All right. Thank you, and have a good evening, all.
You too.
Yeah, okay. Bye.